everyone, you are welcome to today's class. Our topic today is resolution of more than two vectors. In our last lesson, we learned how to resolve a force F acting at a point O at an angle theta to the horizontal into two components, that is the horizontal component Fx and the vertical component Fy. When a body is subjected to several forces, more than two forces, to find the resultant force acting on the body, we will need to resolve each force F in two perpendicular directions, its horizontal component Fx and vertical component Fy. Horizontally, Fx will be equal to F cos theta. Fy will be equal to F sin theta. We will use only the angle to the horizontal. The next thing to do is to add all the x components together, considering the direction of the resolved force, and add all the y components together, also considering the direction of the resolved force. Let's consider a system of three forces acting at a point O. These forces are F1, F2, and F3, acting at theta 1, theta 2, theta 3 to the horizontal. We will resolve each of these forces in two perpendicular directions, that is the horizontal component x and the vertical component y. A vector can be positive or negative depending on its direction. In that system, we have four quadrants. In a quadrant, the first quadrant, the x direction is positive, the y direction is positive. In the second quadrant, the x direction is negative. So any vector we resolve to the negative direction in the second quadrant will be negative. And the y direction is positive. In the third quadrant, both the x and y direction are negative. In the fourth quadrant, the x direction is positive and the y direction is negative. So looking at that system, we have four quadrants in that system. If we resolve F1, we will get F1 cos theta 1. And resolving F1 to the vertical direction, we have F1 sin theta 1. We want to resolve F2. Resolving F2, we'll have minus F2 cos theta 2 in the x direction. In the y direction, we have F2 sin theta 2. Resolving F3, we have F3 horizontally as F3 cos theta 3. And vertically, we have minus F3 sin theta 3. At this point, we will add all the x components together and add all the y components together. We will then find the resultant of x and y by using the formula r squared is equal to x squared plus y squared. The direction of the resultant force is given by tan theta is equal to y over x. Now, let's take an example from NECO 2020. Three coplanar forces of magnitude 8 Newton, 5 Newton, and 12 Newton act at a point as shown below. We are given a diagram there. Use the information above to complete the table below. A table is also given, and you are asked to calculate the resultant of the forces. To do this, if you look at the diagram, you are given 5 Newton. 5 Newton is in the second quadrant, and the angle to the vertical 70 degree is what you are given. You are going to subtract 70 degree from 90 degree to get 20 degree, the angle to the horizontal, because 20 degree and 70 degree are complementary angles. Also, in the third quadrant, you are given 12 Newton. 12 Newton, you are given 55 degrees to the vertical. You cannot use that angle. We only use the angle to the horizontal. So we will subtract 55 from 90 to get 35 degrees. We are using 35 degrees. Then we are given 8 Newton acting directly downwards. 8 Newton, the angle to the horizontal for 8 Newton is 90 degrees. So the best thing to do is to draw out a table where you write the force and the horizontal angle. So the force of 5 Newton is acting at an angle of 20 degrees to the horizontal. The force of 12 Newton is acting at an angle of 35 degrees to the horizontal. The force of 8 Newton is acting at an angle of 90 degrees to the horizontal. The next thing we'll do now is to resolve each of these forces. Let's take 5 Newton. We will resolve 5 Newton to the vertical as 5 sine 20 degree. Resolving it to the horizontal, we have minus 5 cos 20 degrees. We'll take 12 Newton. If we resolve 12 Newton to the horizontal, we have minus 12 cos 35 degrees. If we resolve 12 Newton to the vertical, we have minus 12 sine 35 degree. We'll take 8 Newton. If we resolve 8 Newton, we will have vertically, we'll have minus 8 sine 90 degree. Horizontally, we will have 8 cos 90 degree. We won't take the negative side. We will take the positive side. We get our table. We put it on a table, the x component and the y component. Horizontally, for the x component, we will start with minus 5 cos 20 degrees. Then we'll take 12 minus 12 cos 35 degrees. Then 8 cos 90 degrees. On the y component, which are the vertical components, we'll have 5 sine 20 degrees, minus 12 sine 35 degrees, and minus 8 sine 90 degrees. Looking at the table we have, we will substitute in all the values of the sine and the cos. So we start with the x component. We have minus 5 cos 20 degrees. 20 cos 20 degrees is 0.9397. If we multiply this by minus 5, we will get minus 4.6985. Then we take minus 12 cos 35 degree. Cos 35 degree is 0.8192. We multiply this by minus 12, we get minus 9.8304. Then we have 8 cos 90 degrees. Cos 90 is 0. Multiply that by 8, you get 0. We go to the y component. We have 5 sine 20 degrees. Sine 20 degrees is 0.3420. We multiply this by 5, we get 1.71. Minus 12 sine 35 degrees. Sine 35 degree is 0.5736. We multiply this by minus 12, we get minus 6.8832. Then we go to minus 8 sine 90 degrees. Sine 90 is 1. 1 multiplied by minus 8, we get minus 8. We'll add all the x components together. If you add all the x components together, you will get minus 14.5289. If you add all the y components together, you get minus 13.1732. So both x and y are acting in the negative direction. To find the resultant, we use our formula r squared is equal to x squared plus y squared. When we substitute in our values, by the time we square both of them, they become positive, and that will be 210.86 plus 173.53. When we add them together and find the square root, we'll have 19.61 Newton. We can now find the direction using tan theta is equal to 13.17 divided by 14.52. If you divide that, you will get 0.9070. Finding the inverse of that tan, your theta will be equal to 42.21 degrees. That is the direction of the resultant. I hope you enjoyed the lesson. If you have any question, do not forget to drop them at the comment section below and I'll respond to them as soon as possible. Do not forget to subscribe. Bye.